Once you get out of the beginner or intermediate stages of programming, you realize quite quickly that there's a variety of other skills that you need to have to be an effective and efficient software engineer. Now, many companies will teach you these skills, which is great. However, if you're going to an interview and you already have some of these skills developed, it's going to make you stand out as a candidate, so I want to share those with you today. Now, just as a quick side note, most of these skills you can learn from my courses, Blockchain Expert and Programming Expert. Check them out from the link in the description. There's probably a holiday sale going on while I'm releasing this video. Regardless, let's get into the skills. So the first skill that I have here is Git. Now, I know this seems obvious, but when I say that you need to know Git, I really mean to have a thorough understanding of how Git actually works, what a branch is, what different commits are, how you change history, what's the difference between, say, a rebase and a merge, what happens when you pull a branch down, how do you kind of fix a mistake you've made in a Git branch, how do you revert a commit, how do you cherry pick commits from different branches. You should have a thorough understanding and be able to use this very quickly and pretty much have most of the commands memorized. Now, I can tell you that over the past few years using Git, I've had countless hours where I've had Git problems and I've had to copy folders, delete folders, and do all kinds of weird kind of janky stuff because I didn't know the correct Git commands. So it's completely worth spending a few hours to really dive into Git, understand how it works on a lower level, understand how to properly create a pull request, how to make sure your history is linear and clean, how to remove commits, how to change commits over to different branches, how to pull down existing branches. There's all kinds of advanced and kind of nuanced Git features that you're only going to run into when you need them and when you make a mistake in a production code base, but it's definitely worth kind of diving into that, learning all of the nuances of Git and having a good understanding. It's going to save you a ton of time and also means that you don't have to now message your supervisor and say, hey, I made a mistake on this branch. Can you tell me the Git command? All right, next skill that I have for you here is testing. Now, this is something I despise doing. I always procrastinate writing my tests. However, now that I'm working for a startup, you guys know I have a company called Velocity, I really need to be testing all of my code. Again, it's something I absolutely hate doing, but to be able to feel confident pushing code into production, it has to be tested, and this means I have to write code in a specific way such that I can actually test this code. When you start getting into kind of, I don't know, the more advanced levels of programming, you realize that everyone you're programming with knows how to solve a problem. They can create a web page, they can create a function, they can write a backend. However, not everyone can write this in a way such that it can be tested easily. Testing your code is a very difficult thing, especially if you have very complicated code, especially when it comes to handling all of the different edge cases. And if you write very, very complex code, it can be really time-consuming to test it. So it is 100% a skill to understand how to test your code, and more importantly, how to write code in a way such that you are able to test it and you can actually catch any bugs before you roll that code out into production. So please spend some time learning testing, learn about different types of testing like unit testing, integration testing, system testing, etc., and feel comfortable writing tests for the code that you write. So moving on, I have the topic of system design. Now, this is a very vague topic. It kind of encompasses a lot of different stuff, and system design could mean like designing different servers, designing a database. It could also mean designing different classes, functions, modules, etc. that you're going to have inside of a code base. At minimum, I think most programmers should be comfortable understanding how to break, say, a class into different functions or different methods, how to have maybe multiple classes interacting with each other. Maybe you want to have a basic understanding of how you should have kind of data set up in a database. That's kind of a different topic, but that could kind of roll into system design. Alternatively, system design, again, could be setting up servers, it could be having load balancers, it could be understanding how to scale. That's kind of a more complex topic that most regular developers are not going to have to handle, but I think it's important for most programmers to have a kind of general sense of what is meant by system design, the process of doing that, how you look at a system as a whole and kind of break that into subcomponents, and at minimum understanding, okay, I want to have, different files in my code base, I'm going to organize those into folders, just keeping some kind of structure to make sure your code is somewhat maintainable and you have some kind of, method to the madness when you're writing a ton of code or a feature. So moving on, I have a topic that's highly related to system design, and this is scalability. specifically writing scalable code. Really what I mean by this is being able to think about how your code is going to scale to maybe tens of thousands, hundreds of thousands, potentially millions of users, and if it's actually going to be feasible to say run on, a million entries in a database, or to be ran every few seconds, or how long it's going to take if you have a ton of different entries that it needs to process. This is something that you only really start developing when you're in some kind of critical environment where you actually need to write scalable code, because in most cases, if you're just working on a hobby project, or you're on a small team, or for a small company or a very small product, it doesn't really matter if your code scales. If you're only serving 10 people or 100 people, it's fine if you have fairly slow code because you have a very small amount of users it's going to be kind of servicing, right? Or a small data set it's going to be processing. However, once you start servicing tens of thousands or hundreds of thousands of users, it can become really detrimental and quite expensive, maybe even unusable, if you write code in a way such that it just can't handle that volume of data. So we've all seen the coding interview questions where you have maybe an n cubed time algorithm, you're asked to bring that down to maybe n squared or log base 2 of n, etc. There's a reason why they ask you to do this, and it's because they want to see how you think about creating code that's actually going to be scalable. So I'm not saying go and do a million leak code questions. I'm not saying that's the way that you're going to learn how to do this, but I think it's important to really think about every time you're writing code, okay, is this going to scale? Is it okay if it doesn't scale? Is there a way I can write this more efficiently? Can I make this more cost effective? For example, in terms of maybe reads from a database, should I change the schema, how I'm kind of reading data in? All kinds of different things to consider here, but it's worth thinking about scalability as you're getting better at programming and trying to practice that even in your hobby projects. So continuing here, we move on to the last skill, which is documentation. Now, this is something that everyone hates doing. I don't know anyone who enjoys writing documentation, but it becomes very important when your code starts getting larger and when other people are going to be reading and understanding it or attempting to understand it. So when you're just working as a solo developer or in a very small team, you might think the documentation is unnecessary and a waste of time. And in some cases, you may be right because you understand the code, your team understands the code, you know where things are, you can ask someone if you don't understand, but as you start scaling and having more members, it becomes very time ineffective to not have documentation. Because that means now all your new developers have to spend, countless hours reading through the code base, trying to understand what's going on. Whereas if you had just written a 1 or 2 page kind of document or summary, or maybe you had, just a basic kind of instruction set of what's happening, what this code is doing, how you, contribute to the code base, etc. That would save you from maybe having to explain this to them or kind of train them on the code base, and it would save them from having to read through all of the source code. So I think it's definitely a skill to learn how to write documentation, even if that's just basic documentation, and how to kind of take your code and summarize that in English, right? And explain, this is what the code's doing, this is how you add to it, this is how you change it, this is what's expected, this is the output you're going to get from it, etc. So it's worth doing that. Again, probably a waste of time if you're just working on a solo project, but as soon as you start getting into some kind of team environment, definitely consider, especially for critical features or ones that other people are going to work on, writing at least some minimal documentation that gives some instruction or at least a starting point to other people that might be diving into the code base. Alright guys, so with that said, I think I'm going to wrap it up here. I decided to make this video because these are skills that I've noticed becoming more and more important as I've gotten better at programming, started having other programmers work with me, kind of being in a more, large code base with tons of stuff going on. And I wanted to share them with you because I find a lot of videos don't mention this, and in a lot of courses, it's kind of impractical to teach these types of topics or even talk about them because it's hard to really see the importance of them until you start getting into a larger code base, you have a team, you're in a workplace environment, etc. As I said, I think many of you are going to learn these skills as you get better at programming, as you're working in some kind of job. But in the meantime, it's definitely worth considering them and maybe reading a book or two, watching a few videos, articles, lectures, etc. Regardless, I hope you guys enjoyed. If you did, make sure to leave a like, subscribe to the channel, and I will see you in another one.